For our third example regarding work, we'll try and combine a little bit of everything. So what we have here is an 18 kilogram block. We'll assume was originally at rest. And if I apply a 200 Newton force that acts 30 degrees from the horizontal axis, how long, over what distance, do I need to apply that force in order to give that 18 kilogram mass block 20 meters per second of velocity? So in order to do that, we'll do as we always do, and we'll list out our equation, and we'll take stock of what we have here. So the first thing to recognize here is that we can actually use the change in energy portion of this equation, because we know that the final energy will be kinetic energy. So 1/2 the mass times the 20 meters per second squared, that's what we are looking to achieve. And we're going to subtract from that 0, because as I said, this block was originally at rest, so it has no energy. So if I solve that out, we'll directly find out that the work that I need to perform on this specific block in order to get it to move at 20 meters per second is exactly 3,000 joules. Now, that's not what the question is asking, but figuring out how much work is required, how much energy is required to give to this object before it'll obtain the results that we're looking for, I can now go and connect it to the other aspect of that equation. So knowing the work is 3,000 joules, I can then set that equal to force times the distance times the cosine of the angle. So the work, as we've determined, was 3,000. We know the force, which was given, was 200. Distance is what we're looking for. And in this case, the angle is 30 degrees because the distance is to the right, and the force is being applied 30 degrees from the same axis that the distance is acting along. So if I plug all of that in and I do my algebra correctly, and I am in degree mode because my angles are in degrees, I should find that if I stop applying that force after the block has moved exactly 17.32 meters, that's the moment at which it should be traveling at 20 meters per second.